Greetings pre-calc students, this is Mrs. D, here to do some more trigonometry problems with you. These problems are more analytical trig, where we will find ourselves drawing triangles to represent scenarios rather than waves. In our first example, I have drawn a terrible drawing of a car moving toward a building. Now I purposely drew my car so it was hard to understand which direction it was headed, but we will continue reading here. The angle of depression of the car changes from 22 degrees to 46 degrees, and that angle of depression is coming from a person who's on top of the building, their eyes from a horizontal to the car. So there's the first angle of depression, 22 degrees. And then, yes, the car is moving closer, and so that angle becomes a greater measure of 46 degrees. So there's the 22, here's the 46. The closest that the car would get to the building, of course, before it passes the building is at a 90-degree angle of depression. What we're trying to figure out is how far the car travels, which is unknown to us. I will label the unknown here. So it was here first, and then moments later, it was here. How much did it move? That's the question. Well, in order to do this, we're going to need to set up a triangle situation. Right triangles will be our friends here. Notice the building here is assumed to be perpendicular to the ground. And so I'm actually kind of looking at two right triangles. I'll look at this one first because it's most obvious. I'm going to label this with another unknown measure, but I think if I could figure out this measure y, and then ultimately this measure, I'll call it W, the difference between those two would be the distance that the car has moved. So given the angle measures here, I can transfer alternate interior angles because the ground is not perpendicular, parallel to the horizontal line of sight. Likewise, the ground is still parallel to the horizontal. We will set up a tangent ratio dealing with each one of those angles eventually. So tangent of 46 degrees here will be represented by the comparison of 100 to y. I will solve that for y by multiplying on both sides and then dividing. Now before I go any further, make sure you have a calculator. Calculator is required for these problems. And make sure you have batteries in the calculator. And then make sure your calculator is in degree mode, because if you solve these using radian mode, you might even get some negative measures and you'll scratch your head and say, something's not right. So this measure is 96.57 approximate feet. And I will continue with this larger right triangle formed with the angle 22 degrees, the building and the person on top of the building. Similar process. Tangent of 22 degrees will equal the comparison of 100 to what I'm calling W, this full length. Keep in mind sine, cosine, and tangent don't really make sense or don't have value unless they are within a right triangle. Then we're talking about opposite, adjacent, and hypotenuse measures. If you solve here for W, W will be approximately 247.51 feet. And neither one of those is our answer. Remember, we're trying to find the distance that the car moved. And so if I subtract those two measures, W take away Y, we will get our distance that the car has moved, which in this case is approximately 151 feet. Exact 150.9. Not exact either, it's just a different type of rounding. That's how much the car moved. Not too much. Enough, we'll say. On to example 2. In this example, we have a non-right triangle. It's an obtuse triangle that I'm seeing here. And this obtuse triangle has one angle given. And actually this triangle's height is also given outside here. That's a height. It goes from the highest point on the triangle to an opposing base in a perpendicular fashion. So I'm calling that a height. And we are actually going to have to use that to indirectly find all of these other measures. So So the first thing I see, or I would find, is the measure of A, and that's here in this right triangle on the external part of the triangle. This would be a good time to use a sine ratio. So sine of 48 degrees is the comparison of 21 to A. Now you could also say that the cosecant of 48 degrees is A over 21. And either way, you're going to do some multiplying with 21, whatever those units are. And you should find that A is approximately 28.258 units, whatever those units are. And now that I have A, I'm going to find C. And maybe you could have found C at the beginning. It wasn't the first thing that came to my mind, so I'm going to find C here, utilizing this larger right triangle. In a lot of ways, this reminds me of the problem that we just did, except for we have many other measures to find, and it's going to take a few more steps also. So again, dealing with this right triangle, I will set up a sine ratio. Different angle this time, 31 degrees, which means that sine ratio is probably going to be smaller. 21 compared to C, and yeah, C is going to be a bigger measure, very likely a longer unit of length if I multiply by C on both sides. Again, make sure your calculator is in degree mode. Divide by sine of 31. And I should get an approximate measure of 40.774 units. Do you like how I'm going to 3 decimal places? I don't know if I like it. The last measure to find here, A, it might not be so easy to find if I look at the obtuse triangle, but I'm going to come back to the exterior right triangle that's formed here. And I'm actually going to do one more calculation, intermediate calculation. I'm going to find this length here. I'll call it, I don't know what I'm going to call it. I'll call it question mark. If I know that unknown measure, I can find A simply by using Pythagorean theorem. So that unknown measure, let's see, 21 squared plus this unknown measure squared should equal A squared, which is 28.258 squared. And if I do my math correctly, question mark squared is about 1,221.519. Oh boy. Of course, that's not my measure. I'm going to square root, and I get, this may be very difficult to read, so make sure you're listening to what I'm saying. This question mark measure here is 34.95 units, and I'll use that, like I said, in the Pythagorean theorem. So the unknown length will be, I apologize, after a short commercial break I realized that what I've been finding is not this measure, but this entire length here. I thought that seemed kind of long. And I was using not A, but I was actually using C. So I'm sorry to go back on what I was doing here. But my calculations probably were like, what you doing there, Mrs. D? Something doesn't seem right. I use this 40.77 number. And this 21. I'm going to find this length here. That is what we find is 30.95. And I'm not going to use Pythagorean theorem again, but to find B, no. What am I trying to find, kids? Yeah, I'm trying to find B. To find B, I'm going to take the 30.95 and subtract this measure here, which is 18.908. You know, this is usually an easy thing for me to do. Good thing I'm having a sick day today. My brain is working at a less than 100% efficiency here. So B finally, whoa, end of a short problem, is 16.042 units. And that again was found by using Pythagorean theorem and deducting the measure of this unknown length. I actually did Pythagorean theorem twice, unbeknownst to you. You could probably find an easier way to do that problem, and I encourage you to do so. In this third example, this is the